Let me turn down the volume so I can hear myself talk. Right, making a video. So, I think this might be my only other public one besides my one for my friends showing off me at Montana, blah blah blah. So, what is this video? This is me responding to the good Changeling. He asked some questions, wanted a discussion, so I'm gonna say what my thoughts are on his 3 questions and why. And I'm also going to talk about, so that's 3 things. And I'm also going to talk about what I think a discussion is, just so to avoid, because just kind of like lay the idea of what I'm thinking of what you're saying when someone replies back, whether it's the good Changeling or if it's someone else. This is just the Google Docs of it. And started from like all his comments here. Like this was my first reshared post. I think in my first, or no, I posted it 3 times. Like I was, what is it, October 18th? I've been here on Google Plus for more than a month now. So now I learned it and we talked about that, then we had a discussion, talked about this story. Now I'm not going to explain too much, unless I can read his comment. Spoilers, I guess. No, maybe I shouldn't. I really dislike spoilers. Oh yeah, and I'm playing music in the background just because I wanted to try if that would do anything. This time I don't have a Skype call in the background either, with people just coughing in the background while I'm talking who are louder than me. That was funny. Or no, it wasn't funny, it just sucked. But it really shut up the argument people were having with me. I just like, so blah 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 blah. But in that video, I figured out my definition of what I think argument, discussion, and debate. So right after the questions, I kind of talk about what discussion. Let me clear that up. So I think when it comes to talking, speaking, writing, typing, texting, there's 2 types of there's 3 types of dialogue you can have in the sense of argument, discussion, or debate. And with the argument type of thing, that's the type of thing we got the 2 kids like, I'm right, no, I'm right, I'm right, I'm right, and that's just because of and that's basically, kids like, no, I'm right, no, you bit me first, no, you bit me first, whatever type of thing. They're kind of ignoring what they're saying. Now, people could say, oh, I'm having a debate, and I've had one person who was like, no, we're having a debate, it's a discussion, and I don't think it is because it wasn't productive, and they said it's productive, blah blah blah. But basing on what is productive or what allows talk to be productive, that's what I label a argument, discussion, or debate. Now with an argument, you just got the 2 saying I'm right, I'm right, I'm right, and they can listen to each other, but they can point at no, you're the dumb song. You're dumb because you think the sky is blue or something, stuff like that. But with a discussion or a debate, there is something productive. Now, with the discussion is what I focus on, like the first few pages of this. If you actually want to read it, I'm just saying all this so you don't actually have to read it. But with the discussion, you have, and I think it would be easier for me to get what I'm trying to say across. Writing isn't the best for me. But discussion and a debate, there has to be some progress made. And with a debate, it's basically forcing a form of progress in that you have 2 people, Bill Nye, Ken Ham, I'm right, no, I'm right, I'm right, this is where you're wrong, this is where you're wrong, type of thing. They are going to hold their ground, just like 2 people just arguing. There's 2 ways you get a successful debate. You're either debating so you can find the best or the right answer, whatever it is, best or right, the most fitting answer or the most satisfying answer between both of you. You both think 2 different things, but at one point, either one of you has to realize, oh, I see your point, I agree with you, and then you have you're on one side, or you both realize, oh, we should look at this. Oh, we're both wrong. And then they all go into this new solution. But there has to be change. Progress is a definition of a type of change. Change does not necessarily mean progress or forward moving, but like you can progress through a system and it's a cycle type of thing. Some people say that's not a form of progress, but there's like different types of different levels, different types, whatever. That's just how I'm defining it. I like to think about it. But so that requires a change, and which is not what you're going to get with an argument. Now that's only if you're willing to change type of thing. If you're not willing to change, I think I was going to throw in Mooney's what is it, made up minds. I don't think I threw that in. I think I want to throw that in, but yeah, I'll leave it be. That bugs me now that I didn't throw in Mooney's made up mind. What's I going on about? Fuck me. Discussion, debate. The other time you force it to a debate is when you have a set end, such as we have an hour, blah 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 blah, recap time, blah blah blah, and then you leave it for a majority to figure it out, such as the jury. And then it's the jury who have to do the debate where they have to all side on one side, or at least in America, type of thing. Or, you know, everyone has to believe the person's guilty and then guilty verdict. Now, a discussion is not a fight. It's a good thing. You're having fun because I believe the purpose is so. I think I say it in here. A discussion with me or another person is friendly and is for the sole purpose of learning and exploring ideas, just for the fun of new views, new ideas, and having a new perspective and playing with stuff while I'm trying to talk. And so that's what I'm hoping is here. This is me explaining my views, talking. Now, when it comes to disagreement, you don't disagree with the person to say, or like talking about morals and stuff, but when you say you're stupid, that's an insult. That's direct attack on a person type of thing. So if you say you're stupid because of this, well, then you're making an argument, and like I'm not stupid because, and then you explain that why the argument's wrong. Then you're just attacking the arguments or the cases or the claims or the things. You're not actually targeting the person. Therefore, shouldn't be a direct attack on someone. However, if it's like my skitty monster, he is absolutely true, and if you say he's wrong, you're attacking me. That's the principle that science is not about. You should not be. When you make a claim, it shouldn't be personal, because if it's attacked, then it's attacking you, and then you're going to defend it for your life. And that's like you being a lawyer rather than a scientist, where you're just trying to find the best explanation. You're not just defending what you think is right. But you kind of do in a discussion, but you don't defend like I am right. You explain why. This is what I think, and that's because of subjective experience type of thing. From what I've learned, in my experiences, this is what I see the situation as. And that's pretty much what's going on. So if you have a disagreement, it's because somewhere there's something different experiences, whatever, and we need to find that root thing for it, because that affects the top. So if you don't agree with something, it's usually an argument. You're trying to figure out how I made a connection. Something you ask why. Now you don't just ask why I'm thinking. That's kind of why I'm trying to explain this. I'm trying to reach halfway. If you don't understand something or don't agree, ask yourself and ask me. We try to explore the idea type of thing, and that's the point of, I think, of discussion. It's just exploring, and it doesn't really matter what's right or wrong. Like often you kind of make it sound like an argument. Like when I talk with my tech friends, it's oh yeah, but if, like, when you're saying you disagree, you don't disagree, you just don't really care. You just say, with this type of perspective, perhaps it's your own or something else, with these kind of situations, this context, it doesn't look like that, it looks like this. Oh, that's interesting, but that's just two different views. Which one's right? No one cares, we just play with it type of thing. So I provide a whole bunch of information to play with. That's all we do. That's why it's a fun thing. You don't care. You just think. You don't think what's right. You can say what's right, but you explain the context of why, type of thing. And then you can focus on the different arguments. So if you attack an argument, and assuming you're not taking it personally, you just destroy arguments and stuff. And of course it's going to hit you personally, and you got to look over that. And I like talk about this thing where I'm exploring and stuff. I don't know. So yeah, the good Changeling was talking to me about this. Friendship is optimal. Chondrous. I don't even know the word. But to the 3 questions that came out of it, which kind of gives you a theme of what's going on, this is what I'm answering. Do I think in the next 100 years, or any other time span, could we have the technology achievement to make AI that is self-aware, and why? Second question, assuming the technology potential to make self-aware AI, could these AIs then think they could try to control humans, kind of like what happens in iRobot, or maybe to the extreme point where it's like Terminator, and why? Do I think it's possible to, and then the final one was thrown in, do I think it's possible to upload a human mind to a computer, or is there something more to it? And of course, why? Like, type that in there, why? You're looking at stuff. Assuming you've seen, after like, I don't know, 6 hours, YouTube uploads the quality to like 720, I don't know. But my screen used to be at 720. I think I'm recording at full screen, which is like some warped type of thing, which makes no sense. And I think it's going to mess up with the pixels. That's why I usually record 720p. And I don't think I did that this time. But notice in all my questions, I at least give myself the why. I can say what I think, but it's not really too constructive. If we like look at why and kind of elaborate on that, then you got a discussion. So let's go to the first question. First question is the longest fucker. It's just the longest one. Okay. Do I think in the next 100 years we could have technology, that makes stuff aware? I think yes. I think it's very possible that within the next 100 years we have the technology achievement to make AI self-aware and blah blah blah. I think it's very possible. You know, there's many people working on stuff, and I'm working on stuff. But the reason we haven't reached that yet is because both we haven't made this stuff, and we've hit limits. There's limits to what we can currently do, and there's workarounds sounds plural. And my first one is Moore's Law. Now I kind of going to explain what that is, but it's pretty much dead, or was dead in the classical sense, but it's been revived by NVIDIA. And that's because what Moore's Law is it says that the computational power of our devices will double every 18 months. And that's because every 18 months we keep improving the technology that's used to make integrated computer chips, and we keep improving them to the point where they're able to make the components smaller, and when they're smaller we can fit in twice as many transistors into the same space as space before. And more transistors means more computing power, because those are the things that make the brains, all of the logic circuits, the memory circuits, the whatnot. However, it was about to die because we have hit the limit of the nanoscale. We've gotten so small that if we try to go any smaller, we'll have electrons be able to fly off randomly, because the quantum physics is fuck all to all organized senses and whatnot. So our controlled system wouldn't be controlled if electrons are going fucking everywhere. And so we can't get any smaller, so that would be like the death of Moore's Law, because we can't put in more stuff. But there are many workarounds when it comes to issues and limitations. Now in NVIDIA, I'll put a link in here. NVIDIA, what they did was I go explain it in deeper depths, I think near the end, but turns out I didn't click with me, but So, you know, they make chips and they make them by layers. Same thing with printed circuit boards or PBCs. They mostly have all the traces, the hardware, on a horizontal plane. So you connect it that way. But, however, there was limitations to that. And they want to, like, you know, give better organized stuff. And so what they kind of did was they made their GPU, and this was for like the Titan Z. And they use Titan's like a name that's completely being abused currently for some reason, I noticed. But you take this chip, you make it, and then you punch holes through it, and then you make data pipelines so you can actually better connect different layers, and that allowed for more computational power. And so that way they can continue to expand into Moore's Law and whatnot, and because it's doubling, it's growing exponentially type of thing. So within the next 100 years, assuming that we continue that on that rate, 15, 20 years, we would more than match the human brain and amount of whatever computational power stuff. So, and I say however a lot in this. I don't know if I'm actually going to be saying that. I could have swore I had a link around here somewhere. So yeah, I talk about that. What do I talk next? What do I talk about? Oh, and so that's just, you know, chips, the brains part, and that's usually just the small end of the hardware or a specific part. Another part I want to talk about that, and I'm talking about is, so we're improving things, we're figuring out new techniques, but there's also new things being made. There's like nanotubes and graphite circuitry. They've perfected their making of that, the refining of it, so that they can actually do something with it, because I mean, it's so stupidly small, they couldn't do anything with it. Now they at least have the potential to. I think they're perfecting the processes. I think at my school we've perfected a graphite making, but now it's making that circuits. That's like 1 atom thick long connections, but I don't think too high of a future for that, other than, you know, nanomaterial that could is intelligent, like, you know, self-cleaning cars that power themselves by the sun that hits them, whatnot, or the static breeze that goes by them as you drive. But I talk about memristors, and this is like the holy grail of electronics, and pretty much just as mythical, or depending if I don't know what the current status of holy grail belief isn't. There's like Mooney, and then there's Mooney Python, and then there's like I think that's also the name of the cup that Jesus drank out of at the Last Supper, I think. So I don't know. Stuff people have been looking for. Anyway, so the holy grail for electronics. Now, I go into explaining a little bit about electronics. So you got resistors, capacitors, inductors, diodes, and ICs. Those are the basic building blocks. Well, almost. ICs technically aren't, but they're building blocks made from building blocks. Such as a transistor is actually like 2 diodes put together butt to butt, but not really, because it's distinct in that you can work with different properties of material because you're integrating them, such as you can make a field effective transistor, which isn't diodes, but it's its own component and acts like a transistor, but it's not like a bipolar transistor where you get the 2 diodes end to end type of thing. So, and then you got, like, you know, different individual chips like memory cells, you got logic circuits, you got the 555 timer chip, whatnot. So these are modular systems, just as the resistor is its own thing, so are these ICs, so that's why I kind of count that as a basic building block. And I'm kind of building up like a case or excuse from a memristor. And with other type of material, you can like make memory cells, logic circuits. I think I go talking to RAM. Oh yeah, because the potential for you got transistors, which are the king currently of technology, solid state technology and stuff. And transistors have been used to improve RAM. They make static RAM, solid state hardware or hard drives now. I talk about RAM a little bit in here, but the thing with transistors, I'll get into it later. But memristors are memory plus resistor equals memristor, because you got capacitors which can store charge, you got inductors that can store charge, you got transistors that can kind of store charge, and the transistors can play with input and make a different type of output. Capacitor can play with input, make a different type of output. Inductors can play with input to make a different type of output. But a resistor is like a constant. You can put in different voltage and get some different whatever type of thing. It's pretty linear. But what a memristor is a resistor that can remember things. It can like change, it can have a value, it can change its value, and it can change according to its input as needed. And a resistor just like resists current, and that's like a I mean, okay, this doesn't have any resistors, but it's so freaking light. You got LEDs. Well, those can only handle so much current, and otherwise you like burn them out. So a resistor is for like limiting the amount of current or power going through something. Type of thing, yeah. But the thing with the memristor is like I don't think I even typed that in. The thing I was thinking. But yeah, I'm gonna type it in while I'm talking if I find it. But so you got transistors which make most RAM memory, and the thing with this is that you have to hook up transistors together to make logic switch gates, and then you have to hook up logic gates to make memory, or at least that's kind of what a set reset latch is, memory cell. And if you try to make that in Minecraft, I use Minecraft as an analogy, it's a fucking big ass thing. But I mean, on the nanoscale, it's pretty big. You got all this stuff going on, and there's like workarounds on that, just as like playing with transistors. So like maybe I think you got an SR type of diode, which is like two transistors squished together, where you got power and then it stays on, and then you got a thing you got to do to reset, and that's pretty much it, and that's memory. But that's a compact version, a compact memory cell, but it's still big on the nanoscale. Now, what a memristor allows of it is it's one component that does just that. It can remember something. And for the most part, since it came up within the 70s, 1971, I think it was. You can find the wiki page. I linked a video to like give you the idea. Which I was very happy to find this video. It was a good video. I remember hearing about these in 2008 when they were like discovered that they actually exist. Up until then, it was freaking myth. HP Hewlett-Packard figured it out and did it. But they are the holy grail, because if you have this one thing, you can replace those things, those memory cells, with this one little component. And this component kind of is self-intelligent in itself. Like, there's many ideas of what a memristor was up until 2008. Now we have at least one exact idea of what it is. Up until then, it was pretty much breaking the fucking laws of thermodynamics. Up until we had one model that worked. Because, whatever. But, so a memristor, you can, it basically really shrinks down RAM to just, it's like, you might see a Minecraft RAM where it's just, you got traces like this, and that's ultra compact. That's what a memristor is. It's a 2 to 3 nanometer square switch that turns on and off according to what power is fed to it. And it doesn't turn on and off, it just changes its resistance like hugely. And you can see the video to understand how, or how much, or whatever. It's a good video. But, so that's ultra compact RAM, and it keeps that information, so that can be solid state hard drive, and it's smaller than any technology we have. It's pretty sure it's the smallest thing we can get. Now, I emphasized components and parts, and I don't know if I talked about it yet, but I think I missed it. But I talked about organs, how they're made of components. Where did I talk about that? I didn't. I talked about that somewhere. I'm pretty sure I did. But so you got all. I think I get to it when I get to bigger systems. So I talked about But saying these, oh, okay, I think this is what I'm talking about. It derp. So, and I'm still talking about hardware, just is it's advancing. We got this better. We got chips that keep growing. We got a memristor, which are a completely new thing, which promise so much type of thing. And I was talking about the next thing is making more complex systems, such as going from our basic plain type of system, kind of like what we have with CPUs and the circuit boards, to like NVIDIA's punching through and kind of make it more 3D, and I talk about 3D circuits. And then I go talking about the brain and how it's modular, and that's a good thing because that's a simple way of engineering. And I learned that. I went to an AI conference first Wednesday of this month. That was fun. I think half of the stuff I talk about is from that. But from everything else, I tried to find the best video I could. And one of them was the brain and how it's modular. And one of the things they found was there's, I think it's over here. Okay, you know the brain's all wrinkly, and that we're pretty sure that relates to memory. Like, you got a baby's brain, it's really smooth. You got Albert Einstein's brain, it's the wrinkliest brain ever. However, this baby's born, and you can see some indents to wrinkles, like pre-made memories or whatever. But there's some wrinkles that are there. I'm wondering why. But we notice everyone has them. They grow. They're like, everyone has a preset few set of wrinkles. And so this woman, I don't think can use her leg, if I remember the search right. And so, the stimulating parts of the brain, trying to get it to see what they can. And they were like investigating these parts of these wrinkles that everyone has, and seeing if, what that is and if that relates to motion. And they went to one ridge and stimulate it. Girl goes to sleep. I'm like, what? She doesn't go to sleep, she just turns off. I thought they did not know what just happened. They turned off the stimulus, and she didn't notice anything. And so basically, after a while, they experimented, and what they did is they asked her a question, asked her, to reply back, and they cranked up the stimulus, the static or whatever, the charge going on the plate, to see what happened, and she would and she slowed down basically, and it wasn't like she was getting tired. She just slowed down and just stopped, like staring like that. It was freaking people out. And then they slowly undid the thing, turned down the power, cranked down the power, and she woke up or continued, and she went from slow back to normal speed. And they asked her if she noticed anything. The only thing she noticed, and this is what kind of spooked them, is that the aide person she was kind of talking to, the question, she noticed that for a moment that person was moving or twitching or whatever a bit faster, and then they were all of a sudden in this one place, which was like the change between when they fell asleep or just stopped thinking, and then the person walked or moved or whatever, and then they turned her back on or whatever. And so at this AI conference, it was basically, they talked about some stuff, made an introduction, and then they had all a discussion. So I'm kind of recapping some of the things that was going on. But so they think they found the connection of what, at least there's some information of what makes us conscious, or whatever, or maybe even the clock that runs our brain. But this was just one instant. And they're gonna look into it, type of thing. But I think right now what they're doing, when the lady was talking, is they're currently looking over medical records and stuff of people who've like gone brain dead, vegetabilized, and seeing if that area of the brain was damaged, to see if there was like a connection, and to figure out if that really is something going on, and then try with other people, see if you can't turn people on and off. So I talk about that, and like how it's because you make systems modular, so you got this thing that does this process, and then you only need a few connections coming out to it to connect with other systems, and that seems to be what goes on with the brain. And I think And that's also how we kind of design our computers and stuff, chips and stuff. And one of the ideas was neural networks. Now, I don't know, do I continue talking about this? Now, neural networks are some things, but it's, no, I think I continue with the talk of how we design stuff. So we got these modular systems, and because the brain's modular, that makes it easier for us. Our computers are binary or digital and in binary format, because that's just the easiest to make. But they don't have to be. And neural networks, they can work with analog values. And like I talked about CPUs and stuff, I got like a 64-bit laptop right here, pretty crappy. And 64-bit makes like this huge ass number. That means with 64 wires, they can be in that many different states. So one could be on whatever type of thing, is binary concept. And you can like divide up the wires to 8 bits so that you have 8 different inputs of like my name Benzaniga, that's 5 plus whatever, my last name. And so I can process things at multitasking, whatnot. But, you know, for one wire you only have 2 states. Then an analog system, you can have without 1 or 2 wires be able to have that many different combination of values, because it can hold so much information or have so much potential in its in that one wire. And I don't know what exactly the studies are, but you know, looking at the brain seems to be a bit analog and whatever. So those are the focus of making analog computers, but those are harder to design. Well, we kind of figured out a process, and that's neural networks. And the guy, the king of neural networks, made the first one, made the fastest one, and the biggest neural computers, was at this conference. And the thing with what was that? Neural networks and stuff. But just as neural networks seems to be more of the perfection of analog technology. But for every limitation we always have a workaround. Like I bring in AM radios, which were pretty limited, and the workaround on some of the issues was FM. Well, not many. I don't think anyone besides the radio industry knows about this. But not even like your radio station wouldn't know about this. Only like the electronics dude know this. But AM is technically better than FM because it has been perfected. But everyone switched to FM, and that's what everyone is using now. So no one uses AM or the hardware that's been perfected and whatnot. But that's what's happening with this analog technology. Is you got first analog computers and stuff, which were kind of pretty much gears and stuff, mechanical stuff, and belts and whatnot. Those were pretty crappy. And then we got electrical systems, and the greatest manuscript in history was the guy who figured out the connection between Boolean logic philosophy and the on-off state of relays, and basically that pretty much spawned computers. And so digital or binary is at the FM of AM and FM radios. But now AM or the analog is being perfected, which is these neural networks. Now, I thought they were interesting and stuff, but I learned about them, and I don't actually like neural networks. I was surprised that I wouldn't like them. Because this, I think, is this the video of... No, this is just it. This video explains neural networks, but they say a computer learns, it has a neural network thing to learn. They don't learn. They don't learn. Not in the sense that I was hoping for, at least, or the standard I have. But neural networks are actually trained and pretty much programmed. Like if you've got a computer, you want it to be designed in a certain way, that's a neural network. So, and basically what it is we have computers that simulate them and figure out what's the best way. You can look at the video to learn more about that. But they're basically programmed just like anything else, designed. They don't actually naturally learn by themselves. You have an input, and you want what the output should be from that input. And it runs through the simulations a whole bunch of times trying to figure out first some random numbers, then it does error correction until it gets it right. Then you throw in a new set of inputs and what output you want, and then you got to recorrect and keep doing it. You just keep doing that. That's why it takes forever to make these things. It's so slow and for it to learn and whatnot. And of course, the more nodes you have, those are like the little neurons of our brains, the more power it has to be able to better understand something, the input, or create a diversity in its inputs and whatnot. But that's still kind of like a form of program. It doesn't really a form of engineering. That's how you can make. That's how I assume this the computer guy, can make these electronic things. And I've seen the old-fashioned neural things. Like each thing was like this big, each node. So you could put it on 9 maybe. Weren't very powerful, but I think he's done his simulations and made more powerful, better things, neurons and whatever, nodes, and works better. But because the objects, they're isolated and they can have input output, you can make them exist in a video game or whatnot, or a simulation. I think I could do it once I figure out how their correction formula thing, if I want to, but I don't want to. For the most part, I've seen some of those what is it, evolutionary algorithms, then there's other type of algorithms. And then I see neural network intelligence, AI, and I think they're pretty stupid. I just haven't found anything too good with neural networks. The thing is, you design these so that you can put in these high information type of things, and they instantaneously, almost, it goes right through the system, and they spit out the proper output. That's the benefit of designing these things, such as your phone will be able to listen to your voice and know what you're saying, and in real time with your own voice be able to translate that to your grandma in Taiwan or whatever. And so that would pretty much be the universal translator from Star Trek. Where did I get that from? I don't think I talked about that at all, but I saw something about that. But yeah, someone was talking about, no, maybe it was with Wiseman. I call him by his last name because he was my teacher, and his name is John Wiseman. But whenever I say his name, it just sounds like Wiseman. He's a Wiseman. So yeah. So that's the hardware. And then you put all these small, greater components together, and you make these bigger systems. You got hundreds of servers trying to simulate a brain right now, and about 2023 we'll have the big deep blue or whatever will be able to simulate human brains and whatnot, or a human brain, but literally every neuron type of thing. And I don't think that's the right way to go, and I get to that near the bottom, midway, I don't even know. But my focus, my interest is actually the programmed AI. And from what I've seen, from what I've tried to get, everyone's project is on the hush-hush. It's you can't get anything from these people. It's the stupidest thing in the world. I hate it. Copyright, and you got your patents, whatever stuff type of thing. I'm not in at least a society for growth. I'm in a society for money. I've never had money, so I hate it. But I want to be able to make, I say right there, I have many dreams, and one of them is that I want to be able to make robots like the MLP characters, and just make them as realistic as possible, because robots is my thing. You want the pony, but you also want, you don't want it just to pull its string and it just spits out 3 seconds of audio. That's stupid. And you don't want to program it to behave like the character, but you want it to actually be the freaking character. So I'm actually trying to figure out AI thinking in a, do I name it here? No, I think I saved that till later. But So it's something I'm interested in. I think currently, I don't know what's going on with AI. There's like a lot of growth, some learning robots, but I don't actually have any information to say what I think others are doing. However, because it is an interest I am on, have been making my own project that I'm perfecting. And just from my experience as a programmer and a deep philosopher, I at least feel like I'm not falling into the theoretical view of a programmer, or it's the old technique of breaking it down to parts, but looking at it more philosophically and then being able to apply that to code, which is, I think, the technique that I'm thankful for going for, and I think what others are short of, what other universities and stuff come short on, is just the lack of diversity going on in their mind. But with my technique that I'm still trying to perfect, so it's not, I'm trying to, I don't even have the time, but when I do perfect it, I plan to make a model example program. I'm looking at something there because I'm planning to show it off in a moment. It's not even much of anything, but for the most part, if the technology evolve to be intelligent itself just from hardware, I think AI will be able to speak up, at least with the idea of what I think my potential method could do, but I can't say much for anyone else's. And of course, then, what is my method? That would lead me to explain that. And the introduction to the very out loud thought of how I read like Aristotle made some connections on how things relate, and then I could even find mathematical equations. And then, I mean, me explaining how I got to the math took me to 70 fucking pages. Oh, and the thing, wait for my laptop to load. Look at the RAM. I can see the light, but you can't see my hard drive light. But so yeah, 70-page paper. That was my final paper for English, high school, 12th grade, and 70 pages. Only got halfway through, so I got an F. I only covered half the things I needed to, but it was more for me. I was doing it more for me. But here it is. Now it's an open document text, which I no longer have that software because. Okay, so the spell checker is, pretty limited. I thought Google Docs at least was better, and so I copied it into Google Docs, corrected it. It still didn't get some words, but I felt like I got better, and I copied it back into Open Document, and it completely destroyed my dictionary, and I have never been able to fix it, so I just got rid of the whole program altogether. So I can't even open these. But I mean, I compressed this for midsummer. I at least understand that is. I got the notes somewhere, but I've been that was just exploring one idea, and I figured out 2 or 3 other things, and then trying to relate them to make one whole big project and whatnot. So yeah. So I think yes, we have the potential for the AI to be of human intelligence and stuff. And it's my focus to make it of human intelligence. Now my second question, assuming the potential I agree with, do I think that these AIs could rise up, that they could try to control humans, such as they did in iRobot type of style, or to the extreme of Terminators? I don't think so, no. To be honest, I think where this idea comes from is actually a misperception of looking over the functions of systems that don't really exist yet, aka the actual AI software and hardware, and it's making some connections that aren't the most solid. It's a slippery slope argument to say yes or no. That's because I'm talking about the future and stuff type of thing, but it's all subjective and whatnot. That I think that was at the beginning of this thing. But how long have I been talking? I don't even want to look. This isn't so long. Oh, 45 minutes. Great. So everyone's asleep now. Okay. I think I'll stop it here. Yeah. I can Break it up into parts. I like that. Okay. Bye. Okay.